In this section, we'll be doing absolute value equations. So the absolute value of a variable x, denoted with these vertical lines next to it, describes the distance of x from 0 on the number line. So let's take a look at this equation, the absolute value of x equals 2. So we're trying to solve this. We're trying to find values of x that make this true. Well, clearly x equals 2 will be an answer because it's 2 units away from 0 on the number line. But what's not as obvious is that -2 is also an answer because -2 is 2 units away from 0 as well. So there's actually 2 solutions here, and those 2 solutions are x equals -2 and x equals +2, and the answer is just written there with brackets written as a set. So when we're solving these, in general, we're going to try to isolate the absolute value first, and then we're going to have the absolute value of something equals a number. And if that number k is a positive real number, then what we have to do to solve this is we drop the absolute value bars and we set whatever is inside equal to the number, and we also set it equal to the negative number, just like we did up here when we got +2 and -2. So something we have to watch out for is if that number is negative, the absolute value of f of x equals a negative number, there's going to be no solutions because the absolute value of something can never be negative. Okay, so let's do a couple examples here. We have the absolute value of x equals 7. So the absolute value is already isolated here, so all we have to do is come up with our 2 equations after this, after we drop the absolute value bar. This means that x equals 7 or x equals -7. So we drop the absolute value bars and we set it equal to that number, and then we also set it equal to the negative number. So now we have these 2 equations to solve, but they're actually already solved for. We don't have to do anything. So these are our 2 answers here. We get x equals -7 and x equals 7. So you can write it the way that I'm writing it, or you can just circle those answers. So if you wanted to check this, put a little check down here. If we wanted to check it for -7, that would be the absolute, so for the absolute value of x equals 7, that's our original question. So plugging in a -7, we get the absolute value of -7 equals 7. That is true because the absolute value of -7 is +7, so we are good. And also checking it for the other one, for +7, we have the absolute value of x equals 7. We plug in 7, and we get the absolute value of 7 is 7, which once again we know is true, so that we know that we are correct with our 2 answers here. Okay, so let's do a couple more. We have the absolute value of x -18 equals 0. So first we have to isolate the absolute value, which means we have to get this 18 to the other side. So that means we have to add 18 to both sides. So we end up getting the absolute value of x equals 0 plus 18, which is just 18. So we have the absolute value isolated, so we do exactly what we did before. We drop the absolute value bars, we set it equal to that number, and then we also set it equal to the negative version of that number. So typically right here we would try to solve whatever's left over for both of them, but once again, these are already solved for, so our answers are x equals -18 and x equals +18. And you can check these both just like we did in the last one if you wanted to. For the next one, we have the absolute value of x plus 3 equals 10. So we already have the absolute value isolated here. So all we have to do is drop the absolute value bars, set it equal to the number, and then we also set it equal to the negative number. So we set it equal to -10. And now we have to finish solving these ones this time. So we solve them separately. On the left-hand side, we have to subtract 3. So we get x equals 10 minus 3, which is 7. And then the equation on the right, we subtract 3. We get x equals -10 minus 3, which is -13. So we get our two answers, negative 13 and 7. And do two more here. So for D, we have 5 times the absolute value of 1 minus 4x, and minus 15 equals 0. So we have to isolate the absolute value here by adding 15 to both sides. And that's going to give us 5 times the absolute value of 1 minus 4x equals 0 plus 15, which is 15. And now we have to divide both sides by this 5 out front. So we need to get that absolute value by itself. We get the absolute value of 1 minus 4x. The absolute value of 1 minus 4x equals 15 divided by 5, which is 3. So we have the absolute value isolated. So we drop the absolute value bars. We set it equal to the number. And we also set it equal to the negative number. So we have 1 minus 4x equals 3, and then we also have 1 minus 4x equals negative 3, so we have to solve both of these separately. So for this one on the left, I'm going to subtract 1, and we're going to get negative 4x equals 3 minus 1, so 2. And then we have to divide both sides by this negative 4. And we get x equals 2 divided by negative 4, which simplifies to negative 1/2. And then for this one on the right, we have same steps. We subtract this 1 on both sides. We get negative 4x equals negative 3 minus 1, which is negative 4. Divide both sides by negative 4. And we get x equals negative 4 divided by negative 4 is positive 1. So we get our two answers here. X equals negative 1/2 and x equals 1. Okay, and then for this last one for E, we have 0 equals 4 times the absolute value of 6x plus 15 plus 20. So first, isolate the absolute value, subtract 20 on both sides. 0 minus 20 is negative 20, so negative 20 equals 4 times the absolute value of 6x plus 15. And we have to divide both sides by this 4 to cancel it. So we get negative 20 divided by 4. That's going to give us negative 5 on the left. Negative 5 equals the absolute value of 6x plus 15. So this is where we have to be a little bit careful here. We have the absolute value equals a negative number. Since the absolute value equals a negative number, there's actually no solutions here because of what we said on that first page. The absolute value of something will never be negative. Okay, so no solutions for that one. Okay, so that is it for absolute value equations.